Alright, let's see here. So in this video I'm going to be improving the initialization code of the LP55231 LED driver, which I'm using on my motor controller. And I'm gonna write some code that is going to use the built-in LED test functionality, which is available on this chip, to determine which LEDs are connected. And I think I should be able to get also at least the voltage that is. I guess that would be the voltage going through the LED, or the voltage across the LED. We'll see. I'll read the datasheet in a bit more detail and see what we can get here. So this is the LED test ADC register is going to contain a value that can be directly translated to voltage. So let's get some code running and get some readings from this register. I'm going to connect my terminal to this control panel, the board that is on the control panel, and I'm going to connect the programmer here as well, so we can get the readings from the button, the buttons which have LEDs here. So this is the LEDs that we're going to be measuring. Let's see. Alright, so get the ground connected there, and then the terminal. And then the programmer. Alice! Alice! Kom hit! Kom hit! Nu! Nej! Bra. Kom. Alright. Nej! Gå lägg dig. She's hearing some noise that she thinks is suspicious. I don't hear any noise, but she does. Alright, let's see here. So, going back to the source code, I've got the source code here, and I'm going to implement this functionality after starting the chip. During the initialization sequence, I'm going to read all of the LEDs and print out which LEDs are connected. So let's see, 4. I don't think printing float is going to work. I still haven't solved that issue. I don't know why it's not working. I need to basically just get down to debugging it and figuring out why it doesn't work. But the easiest way is actually to just print it out as a decimal, as an integer, and express it in millivolts. Let's see. this chip has 9 LEDs. That is nej. Lugnt. Nej. And then we can put it here. Nej. Bubbly. Nej. Kom here. Kom. Kom här. Så, ligg här. Så, ligg. Ligg. Bra. Bra. And then this will, this needs to start the test. So this needs to write to the test control register. Let's see here. And then we need to wait for this to become true. So it's a several step process. Let's see. So where is the LED control register? LED test control, LED test control. Yeah. So let's see. I think it's better if I just look at the description of this register. Where's the description of this register? Reset, temperature right, LED test control. Running bit high, fire single LED test conversion. Okay. This one is going to be 0. Continuous conversion. Actually, this one kind of makes sense because we're not really worried about doing continuous conversions here. We have motors that draw several hundred times more power than this type of test. LED test control, these bits are used for choosing the LED driver output to be measured. Okay. So we're actually, because I have to choose one output, I probably am not going to use continuous conversion. So I'm just going to choose one output, I'm going to fire the ADC, and I'm going to wait until it's completed. That sounds reasonable. So this would be the LED control register, and this would involve writing the register. So let's see here. So I'm assuming that the status register, actually we're not supposed to make any assumptions. So let's read the status register. This actually makes sense to return an int and have the value as a parameter. So if status is if the bit for LED test in progress. Let's see. Where's LED test in progress? First of all, where's the status register? There. So LED test measurement done. Actually, okay, so it's cleared automatically after a read operation. So we don't really need to do this test. I can do this test actually afterwards here. And if status has this bit set, so LP55231 reg status LED test done. Then we return 0, otherwise we return -1. And this takes 2.7 milliseconds, so we need to wait 3 milliseconds. Here I will write to LP55231 reg LED control LED test. Let's write to LED test, and the value would be 55231 reg LED test. So basically the last bit and the LED and this will be the last 4 bits. So this will be ended with 1F. So last 4 bits. We start a conversion for this LED and then wait 3 milliseconds and then read the status. If the status is done, then we read the result and return it. This would be the result. And then what else? I think that's it. And I'll just add the registers here. So LED test ADC is register 42, and I guess that is expressed in hex. Yes. So 0x42. I mean, they must be kidding here. This is like calling this register 0x42. This is the answer to which LEDs are actually connected. is 42. And then the LED test register is 41. Start conversion is bit number 7. Let's see what we get. This has to be unsigned, otherwise it's going to complain that I'm converting signed to unsigned. Just like it did here. I have to power this on, so I'll disconnect the power. Let's see. Flash it. Okay. And this seems to be not working on the first try. So it could have something to do actually with the initialization here. Okay. I suppose that yeah, only control register can be read in standby mode. So I don't think that this actually works. So let's move this over here. And if this doesn't work, then I'll just enable the chip and do everything in the after the power on sequence is done. Let's see. Yeah. What if I enable it first? Yeah. Better. Now it's working. So is it actually maybe the Misc register? I would need to check with GDB. But for now it's working. Let's see. So we have could not read LED 0 voltage. Interesting. Does that mean that LED 0 is just not connected? Or is it invalid value? I'll check here. Yeah, actually it's supposed to be from 0. I'm going to check which LEDs are actually connected. And also this initialization needs to be done afterwards. Here. Reset it as well. Let's do like this. Let's toggle the enable. And power on the chip. And then wait. And then enable the clocks. Measure the LED voltages. And initialize the LEDs with half PVM. And I just want to check which LEDs I have connected. Let's have a look here. So I should have not LED number 0, not 1, not 2, but then 3, 4, 5, 6, 7. And not the last one. The last one is disconnected, I think. Yeah, the last one is just connected to the test point. So let's have a look what this gives now. Okay. Yeah, now it's a bit better. So 0, 1, 2 has a negative voltage, and the last one has negative voltage. But 3, 4, 5, 6, 7, they have positive voltage. It's interesting that the voltages are different. But this is nice. So this can be used to determine which LEDs are actually connected. So I want to kind of write a test that is done on the higher level in firmware to read the LEDs and to output which ones are connected. Based on the meaning of the LED. So for example, I think that LED number 3 is the home. Could it be the home LED? Yeah. So LED number 3 is the home button. And then we have the 1, 2, 3, 4 LEDs for the presets. I'm just thinking what would be a good way to implement this functionality without breaking the abstraction of the LED driver. So I definitely need to have a test to check that the correct LEDs are connected. But this is going to be done only in master mode, so only when running as the control panel. Hello Damien, how are you doing today? How's your project going? If you're watching this live, you should go to YouTube, and there you can take part in the live chat, and also you can join the Discord, for which you will find the link in the video description. I don't know if that link actually works now, because I've had trouble with the invite links, which I think stopped working after one day. So I pasted the invite link that I got from Discord into like a bunch of video descriptions, and none of them work now. Yeah. So now I opted for actually linking directly to the channel. Okay, so the most obvious way to implement this is to export an interface from the LED driver, and this can be something as simple as just a memory interface, which would allow me to just read the state of the LEDs. However, that kind of breaks the whole abstraction thing. It suddenly requires that the application knows about exactly which driver the LEDs are using. So I'm trying to think about some better way to do this, so that I don't have to rewrite the code later. Maybe because this actually is exporting ADC interface, or analog interface, maybe I could extend the analog interface with functionality to get the number of channels. Which could actually include a flag for whether the channel is usable or not. And also, or actually, I got the better idea. I've got the best idea for this driver. I'm going to use the read function. I'm going to implement the ADC read function, which is currently not implemented, which will be used to read the actual voltage on the LED, which is perfect. Let's see. So this will, so if LP55231 read LED voltage, let's see, and this is going to be converted to self. Struct LP55231, self is container of dev, and dev is a pointer to pointer, which points to the member in struct LP55231, and the member is called, I guess, would it be called analog ops? Let me check. Maybe it's called dev ops. Yeah, analog dev ops. Yeah, just like up there. Damn it. So, just like for the write methods. So this will point to. So here I'm telling container off that this dev pointer is actually pointing to analog dev ops. And using this information, container off can give me the pointer to the actual object that owns this pointer, the analog device dev. And now I can call this method self. I can call the method for read LED voltage using this self pointer. And this will take channel and data. And actually, this can just directly return the value. And that's it. And what I can do now is go to the main and add a test. Now the problem is that if there is PWM on this LED, it's going to read a different value. So the place where to do this test should actually be before setting any default value for the LEDs. Let's try this out. So what I'll do is actually just add a method which can retrieve, let's see here. Actually, I will just I'll just add a new command called FB LEDs, and I'm going to put it here. So let's see. I'm going to check if the second argument is LEDs. If it is, then I'm going to print out the information about the LEDs. And I'm going to see what voltages I actually get. So let's have a look here. So this will go through 4 unsigned 0 less than, let's do this less than 9. And actually, this needs to be tested in the LED driver. Just to make sure that, let's see, read LED voltage. Now if LED is more than 9, yeah, then return E in null. And it cannot be less than 0 because it's an unsigned. So let's see, Control O, and now I can, I will actually read up to number 8, because we only have 8 inputs on the board. Number 9 is not used. Analog read, and then it will be switch LEDs, channel C, and volts. And then we have float volts, and we can print it out. So now the values I'm going to be getting here are the values that are measured while the PWM is running. I've checked your company site. Great selection for license 3 class BSD. Yeah, I made this choice after carefully thinking about which license I would use, and I have for a long time I've been releasing a lot of things on the GPL, and I think that GPL is good for certain things, but GPL is kind of it's kind of like it's too much Richard Stallman, I guess, and it has its purpose, but it's not really it doesn't really give the freedom. Like Richard Stallman talks about freedom, like everything should be like free as in freedom, and then the GPL is not really like it doesn't give you so much freedom. It actually puts a lot of restrictions on things. So when it comes to actually selling the code, that like if I use something that is GPL, which by the way I do, and that's a little bit problematic. But the thing is that I can license my code as BSD, but then there can be like other code. Obviously, I use list a lot, like the list that is actually used in Linux kernel. That's licensed under GPL, so it kind of gets a little bit problematic in that sense. But in terms of like selling the code that I write that is like heavily GPL, that kind of gets a little bit in the way. But you know, it's not a problem if I sell my code because I can relicense my code in any way I want. But like relying heavily on other GPL stuff kind of gets problematic, which I try not to do. But I think that BSD is a good license. Like I don't really care. Like, use the code however you want. You know, build on it. I will always have newer versions, which I'm working on. So anything that's out there kind of gets old by the day. So I think that BSD is fine. Are you only one in company, or do you have coworkers? I have my dog. That's my employee right now. My dog is a working dog. My dog is a very good employee. My dog listens to all the commands and is very obedient employee. No, I don't have employees right now, but I'm open to maybe having that in the future. I'm kind of I let it evolve kind of as it goes. You know, I feel very comfortable doing everything on my own, but I think that I do see the benefit of being a team where things can be delivered much quicker and work can be done in parallel. So I do see the benefits there, but I think that a very important thing to think about is kind of having a very clear idea what every person should be doing, so that they can sort of focus on just one part of the work. And right now I feel that I'm doing a lot of different things. So if I once I kind of feel that I have this particular task that I can outsource to somebody else, or to employ somebody, or to contract somebody, then and once I feel that I have time to do that, like to take care of the employees, to file all the paperwork for employees, then I can do that. I have a lot of experience working with contractors, because that's what I've been doing when I was doing construction work, when I was selling construction projects, and that was very nice to work actually with people who are who have their own businesses, because it kind of gets, it's kind of a no bullshit way. Like for the most part, of course, there's like people that don't take their work very seriously, but I find that many people that that are self-employed, they work fast. They give clear, like they give clear answers to how long is something going to take, how much do they want to get paid for it, things like that, and it just gets very simple to buy services that way. What about taxes in your country for small companies? In Sweden, we have very high taxes. We pay around 50%, I would say, in all of the in all kinds of all the different taxes that we have, kind of adds up to being up to around 45% of the stuff you actually invoice, if you use the money for yourself. So if you pay it as salaries, either to yourself or to somebody else. But the corporate tax is 30. So I'm not going to give exact number because it kind of varies. It has to be looked up exactly. But we have a corporate tax, and we have all the other taxes that relate to the employee stuff, like salary taxes and all the little the payments for insurance, and you can look it up if you're interested. GPL is called virus license. No, I haven't checked out Lewis's successor. I'm not really interested to know who Lewis's successor is. I mean, if he's going to be posting some videos that I find interesting, then I would be interested. Otherwise, I don't give a fuck. In other words, yeah, license compatibility sucks. Yeah, I saw that table too. I want to make some freelance stuff. I never had any success with freelance either. I think that, especially if you're doing it through websites that, like freelancer websites, because most of the people that are there, they're from countries where you could make a decent living, if you charge very little for your work. So you have all of these people to compete against, and also the work that you actually get is kind of very random, and you kind of get to, if you have a lot of different small projects and they're all completely random, you never actually get into this flow where you can capitalize on your previous experience. You have to always start over again, sort of. So the method that I feel is the best method to find work is to just go out and visit the companies and talk to them and talk about their problems, see what they want, see what they're interested in, and just do some cold calling. It's very nice. That's kind of that's the solution whenever you need work really quickly. If you really need work today, tomorrow you could have work tomorrow. You could find your employment tomorrow. All you have to do is just print out some flyers, basically make some advertisement for yourself. You could print out your CV, but I think it's better to kind of make something different, like a flyer. So think of it as a flyer. And then you go out and you visit the companies that you think are interesting. So for example, when I was living in Manchester, I was just how old was I then? This was 2000 and this was actually 2009. It was around Christmas 2009. So it's 22. Yeah. So I was kind of I was fed up with doing door-to-door sales in snow and mud and rain, and I decided that I'm just gonna kind of find something that that is indoors. So I did what I just said. I printed out lots of CDs, flyers, and I went out to the city center in Manchester, and I went to all the shops, like Claes Olsson, Primark, all of the shops, and I would go there and I would ask for can I talk to the manager? Can I talk to the person who's doing the interviews? And usually the people that are working there, they would just tell you who the person is, and then you just go and find that person and you talk to them. And that's how I got 2 different jobs after doing that. So I went there. I was doing that for 1 day. So I went. Maybe I visited, I don't know how many shops. Maybe 10, maybe 20. But I got two jobs that day, and I chose the one at Claes Olsson. So I worked there for a month, and I really hated it. but it was much warmer than being outside. And it was very nice learning experience, I think, which really, that time in my life really taught me a lot. And I'm very, I look back at it, and I think I would never trade it for anything else. I think it was great in that sense. TCRS circuits. Okay. Maybe I'll check it out later. Let's see, is this running now? Is this running? Freelance. It crashed. Damn it. It crashed. So why did it crash? Let's check it out. Let's check why it's crashed. Why is it crashed? This is one of the things that I find a little bit cumbersome to do in GDB. It's kind of not aware of free artist threads, so it's, yeah. Let's see. Where did it crash? Oh, yeah. Let's see. So read register, and I'm reading reg 58. And I'm waiting for so let's go up a little bit. PX reg 3A. Which reg is that? Reg 3A, that was the status. Right. Something that I have to check here. Maybe it has some operation that was in progress or something. Maybe it was busy in some way. And also, maybe it was actually at the same time writing something. So I think I have to go through I have to actually review the I2C driver now, because I want to add all the necessary locking to it. Unless I have done so already. have a lock on read, and I have a lock here as well. Which, let's see. So the thing is here that I need to make sure that we are not interacting with any internal stuff in this driver. So actually I think it's probably the fault is in this driver, because this driver doesn't have any locking yet. Does it? No, it doesn't. Okay. Let's see. We need to lock this properly, so we don't get analog write and analog read happening at the same time. So we're going to do like this. Oh, come on. Turn the power. Anything else? No, I don't think so. Maybe this would fix the problem. Yeah, that's what they do on Freelancer. And I would avoid such people that expect Intel Atom board in 3 days. Seriously. And then they want to pay like $1 for it. Okay. Right, this needs to be stopped here. So now I should be able to flash it. That is probably my slowest shell script. Update symbols, because it uses the while loop that is accepting like piped input, and it reads the input line by line, and that's the slowest thing ever. Okay. This still waits for the completion of the operation. I think it's probably still waiting for the status. I'm gonna check this. Oh. Bug? No, okay. Maybe I forgot to initialize this lock. No? No, I have initialized this lock. Ah, of course. I'm such an idiot. I put a unlock here, because I copy-pasted it without double checking. Can't unlock a mutex twice and expect it to be locked at the same time. I'm gonna remove that step from the build process, because because this is going to waste hours of my time. Okay, time to remove the step. I'm going to optimize that script. Like this. And it's still not working. At least maybe it doesn't bug out right now. So, let's see. So check event. And this checks, yeah. It's waiting for the status register. So for some reason, it's impossible to read the status. So we start the test, try to read the status, fail. But why does this fail? Could it be that this chip somehow expects the I2C operations to follow each other? So like if there's something else happening on the I2C bus while this function is waiting, but that somehow screws up the read operation afterwards. I still think you will have more success if you just talk to companies in your area. But that's just my opinion. LED test control. So what is this? I want to check what event it's actually waiting for. What is the event it's waiting for? Master badge received. I know I have to rewrite this I2C driver I have that on my to-do list. This I2C driver is the worst driver in this firmware. This is a blocking, horrible I2C driver that consumes 50% of CPU power. But even if this driver was timing out here, this would still not return the data. So I'm trying to figure out why it actually doesn't return any data. Why is there no response from the chip? So what if I just, instead of reading the status, if I just try to read the resulting value, which probably will fail as well, but I don't know. Maybe it will actually work. Or maybe it's somehow not possible to read this while the PWM is running. I don't know. Some problem. So something is happening after starting the LED test. What if I actually comment out? Let's see. So I'll just disable any writes to this device. And then I can test. the same issue. Interesting. So if I then go back here and I comment out the part that says default values, because when this part is gone, then I don't know what the problem could be. Then it's probably something, some kind of overflow somewhere. Let's see. Right. It's working here, not afterwards. So it actually works. So the LEDs are actually dimming, which at least this one. I can just just click on that one, and actually I cannot power it on right now because I don't have the power connected to the other board. So the LEDs are working, which is going through the same I2C interface. So I don't know why I cannot start the measurement. Only we're using complete modules. Well, I think that there is only a certain amount of things you can achieve with a complete module. It gets tricky when you want to do something custom. You could use Arduinos, but then you end up with a lot of modules, and only that kind of becomes messy. So making a board that contains everything that you need, it's kind of it makes a cleaner design. So I think I know that a lot of companies do use complete modules, but they do it because they have to. Like, they do it because they just don't know of a better way, because they need to get things done. So they try to find a module that best fits their description of what they want to do. Okay. So why is... I can do something wrong here. Analog read, analog write. I wonder where I could even set the breakpoint. Maybe read LED voltage. Let's try to set the breakpoint there, and see what we get. Why is this really 50? Wasn't it 32? Interesting. Did I pass the wrong device to this? Somehow. Maybe I'm passing the wrong device. Let's have a look. Because the 50 is the EEPROM. That's interesting. So, Oh, okay. I have to print it as a hex number. So, yeah, it's actually 32. Okay, so that was not a problem. Maybe I can find some way to configure GDB to always print out hex numbers. Okay. Maybe something else is happening at the same time. It's just screwing up the transaction. So, what if I just disable the SPI transfers? Let's see if I get better results then. Or maybe if I do the transfer actually as part of the main loop, so it doesn't happen at the same time as something else. Okay, this is gonna slow down the main loop considerably, but I'm gonna put it here just to test. So I can actually do like this. This will actually just print continuously, and I'll just remove this text here. But the difference is that now it will be doing it as part of the main loop. Maybe there is some interference between the SPI I2S and I2C. So this does seem to work. least it doesn't hang. But if it happens at the same time as SPI transactions, then it seems to error out. Maybe it is that there is some kind of interference between SPI and I2C. Let's check the wires here. Okay. Yeah. Where is this pin? There it is. Yeah, there is quite a long wire, which had to be this long for the I2C. And it could actually be that there is interference that causes I2C to fail. I'm going to check how fast it's actually running, and maybe lower the speed of the interface. I think that according to the device tree, it was supposed to be running at 50 kilohertz, but that needs to be double checked. I'm going to check the signal at the EEPROM. Let's see. I think that's one bit. I can check SCK just to be sure. I'm not getting any data on SCL line here. So now it stopped. It's quite sensitive. I'm going to check the I2C pins. What if I also enable the pull-ups on the pins? Maybe the clock should actually be push-pull. That would kind of make sense if the clock is push-pull. Okay, so what I'll do is actually I'll just read the I'll read the inputs during the initialization, and then print out an error if running in master mode and some of the LEDs are not connected. But when it comes to actually debugging this, I think I'm gonna have to look at the datasheet and make sure that the SPI signal and the I2C signal are not somehow dependent, like maybe the peripheral flags, maybe something else is dependent somehow. And also I have to check if the data lines could perhaps be getting some interference from SPI, which is actually something that's quite possible when the line is so long. It could be SPI, it could be something else. So for some reason, maybe it's timing out on the read operation. But I'm gonna just check something here. Yeah, and it seems to be running at 50 kilohertz. I'm gonna actually try to up it to maybe 100 or 400, just to use something more standard. Maybe the operation completes much faster if the speed is faster and has less of a chance to fail. Let's try 400. At least it seems to be running. So it went past all of the initialization. So the bus is working. Let's see if it lands. So this is working. Interesting. Okay. Running at. I mean, it could also be that using this baud rate with my current clock is actually giving much better precision for the data somehow. But it shouldn't even matter because I2C is using its own clock. But I don't know. Maybe there is some interference, or maybe this read operation is happening so fast that it doesn't sort of. It's either it fails completely or it kind of completes completely. Maybe the problem will show up again. For now, I can use this to do further testing, but this is definitely something to look into. I've had some problems with the I2C. But what I'll also do is actually refactor this driver to use interrupts. It's going to take a bit of work to get that done, but when that is done, then the driver is actually not going to be blocking, and it's going to be possible to get timeouts, like proper timeouts, so that things don't just freeze. Let's see. I'm just going to fix this printout. This is also going to be a subject for refactoring, because this file is really big. So I'm going to define a struct, and I'm going to have the name of the LED and then the index as well. This is kind of this should be like defined for the board. It's kind of static information. So putting it here is probably not the best place to put it. But for now it can be here. This would be LEDs equals Really. Not so fast. Okay, it worked this time. But there's still, like, there's problems with I2C. But this could serve as a good test. If this keeps failing, then the I2C problems haven't been fixed yet. Okay. Anyway, this is it for this video. This is how to read the LED voltages on the LP55231 LED driver. And thanks for watching.